Hello students, let's discuss few more numericals of the lesson Kinetic Theory of Gases. Question number 19. Calculate the energy radiated in 1 minute by a blackbody of surface area 100 centimeter square when it is maintained at 227 degrees Celsius, where Stephen constant is given, which is 5.67 into 10 raised to minus 8 joule, meter raised to minus 2, second raised to minus 1, and k raised to minus 4. Now, let's write given data. Now here, in this question, calculate the energy radiated. It means we need to find out value of Q, where this capital Q indicate energy radiated. Time is given, which is 1 minute. So time is 1 minute, which we can convert it into second. Then surface area 100 centimeters square. So it means area, surface area is given, which will indicate with capital A. It is given 100 centimeters square. So we can convert that centimeter square to meter square by multiplying it with 10 raised to minus 4. 100 into 10 raised to minus 4, I can write it as 10 raised to minus 2. So this is surface area in meter square. Now one more thing is given, which is temperature, but the temperature is given in degree Celsius. Now we need to convert that temperature in Kelvin. For that we need to add 273 in this temperature, so which will gives us 500 Kelvin. So this temperature is in Kelvin and Stephen constant already given. Now let's find out value of Q. So let's write. Now we are knowing one formula, that is Q upon AT is equal to sigma A sigma T raised to 4. Where Q is energy radiated, A is surface area, T time, sigma Stephen constant, and capital T temperature. Now we need to find out capital Q. So we'll just arrange this formula. A into T into sigma into T raised to 4. Now we'll put all given values. So Q is equal to A. Area is 10 raised to minus 2 times 60. Stephen constant 5.67 into 10 raised to minus 8. And temperature is 500 raised to 4. Now, instead of 500 raised to 4, I can write 5 into 100 raised to 4, which is nothing but 625 into 100 raised to 4, which I can write 625 into, this is 100 raised to 4, right? So 100 raised to 4, I can write 10 raised to 2 raised to 4. So I can write 625 into 10 raised to 8. Now this 10 raised to minus 2 and this 10 raised to minus 8 is 10 raised to minus 10. And then this 10 raised to 10. So instead of this 500 raised to 4, we'll write 625 into 10 raised to 8. So let's write as it is. So instead of 60, I'm writing 6 into 10 into 5.67 into 10 raised to minus 2 and 10 raised to minus 8. I'm writing 10 raised to minus 10 into this instead of 500 raised to 4, 625 into 10 raised to 8. Then this 10 raised to minus 8 and this 10 raised to 8, which I can write 6 into 5.67 into 625 into 10 raised to minus 1. Now we'll just find out this multiplication by log. So we need to write log of all number. So let's write. So log of log of 625 plus log of 5.67 plus log of 6 into 10 raised to minus 1. Then log of 625 is 2.7959. Log of 5.67 is 0.7536 and log of 6 is 0.7782 into 10 raised to minus 1. Then we need to add, and after addition you will get 4.3277. Then we need to see antilog of this number. 10 raised to minus 1 is already there. Now 4.3277 antilog of this number is 2.126. 2.126 into 10 raised to 4. This 10 raised to minus 1 already it is there. So 10 raised to 4 and 10 raised to minus 1. So it will become 10 raised to 3. And when we will multiply the 10 raised to 3 with this 2.126, our final answer which we will get, that is Q is equal to 2126. This is energy radiated, so, or heat radiated, so that is 2126 joule. So this is the required answer for this question number 19. Now let's move to next question, that is question number 20. Energy is emitted from a hole in an electric furnace at a rate of 20 watt when the temperature of the furnace is 727 degrees Celsius. What is the area of the hole? Again, Stephen constant is given, which is 5.7 into 10 raised to minus 8. Now, let's write all given data. In question, it is mentioned energy emitted from a hole in an electric furnace at the rate of. So that is why we can say Q upon T is given, which is 20 watt. Then temperature is also given, which is 727 degrees Celsius, which we need to convert into Kelvin. For that, we need to add 273. So 727 plus 273 will give us 1000 Kelvin. Stephen constant is given to us. That is constant value. And we need to find out area of the hole. It means A is equal to question mark. Then let's solve this sum. Again, same formula we'll be using, which is Q upon AT is equal to sigma T raised to 4. Now, here Q upon T is given, and area we need to find out. So, let's write this formula such a way that it will become easy for us to calculate. So, Q upon T upon sigma into T raised to 4. Now let's put values which are given to us. So 20 upon 5.7 into 10 raised to minus 8 into 1000, which is nothing but 10 raised to 3 raised to 4. Then this 10 raised to minus 8 and 10 raised to 3 raised to 4. So let's solve it. So we'll get 20 upon 5.7 into 10 raised to minus 8 into 10 raised to plus 12. So this part is 10 raised to plus 12. So 10 raised to plus 12 and this 10 raised to minus 8 is plus 10 raised to means 10 raised to plus 4. So 20 upon 5.7 into 10 raised to plus 4, which we can take it up. So this will become 10 raised to minus 4. For 1.57, I am 1 upon 1.57. I am using reciprocal table. So reciprocal of 1 upon 5.7 is 0.1754 into 20 into 10 raised to minus 4, which we can solve directly by multiplication, which will give us 0.3508 into 10 raised to minus 3, which I can write this way in this manner also. 3.508 into 10 raised to minus 4. This is area which we are calculating. So unit is meter square. So this is our required final answer for question number 20. Now let's move to next question. Question 21. The emissive power of a sphere of area 0.02 meter square is 0.5 kilocalorie second raised to minus 1 meter raised to minus 2. What is the amount of heat radiated by the spherical surface in 20 seconds? So it means here given terms are area. Let's write area 0.02 meter square, then time 20 seconds, then emissive power R is equal to 0.5 kilocalorie second raised to minus 1 and meter raised to minus 2. Now formula for emissive power is R is equal to Q upon 80. Now here our task is to find out amount of heat radiated. It means again we need to find out value of Q. So I can write Q is equal to R into A into T. Let's put all given values. So 0.5 into 0.02 into 20. This is simple multiplication which will give us result 0.2 kilocalorie. And if you are getting confused here in this, unit, you can directly multiply. This R is what? R is nothing but, I'll just write this. R is nothing but what? It is a kilocalorie. A means meter square. R is not only kilocalorie, it is, let's write complete unit. Kilocalorie, second raised to -1 and meter raised to -2. This is unit for R. For area, it is meter square, and for time, second. So this way is meter raised to -2 and meter raised to +2. It will get cancelled out. Second raised to -1 and second will get cancelled out. And that is why unit here we are getting in terms of kilocalorie. And we can convert that kilocalorie into joule format. Okay. So here answer we are getting in kilocalorie, which is we can convert it into joule also. Now let's move to next question. Question number 22. Compare the rates of emission of a heat by a black body maintained at 727 degrees Celsius and at 227 degrees Celsius. If the black bodies are surrounded by an enclosure which is black at 27 degrees Celsius, what would be the ratio of their rates of loss of heat? Now, here two questions are given. We need to compare and we need to find out that rate of loss also. So, let's first write given terms. So, three temperatures are given, 727, 227. So, and 27, which will convert it into Kelvin by adding it with 273. Then, first question, compare the rate of emission. So, first we need to compare the emission of a heat of black body maintained at 727 and 227. So, only we'll solve for this part only. So, if you are keeping it at a 727, then what will be the rate of loss? And if you are keeping it at 227, what will be the rate of emission? What will be the rate of emission? So that comparison first we will try to find out by taking ratio. So let's do it in this manner. So dq upon dt for first in the sense for 727 and then for 227, temperature 227. So here we need to assume that area is same. When only we are assuming area is same, so here we can cancel out area from numerator and denominator. So which will become easy for us to find out. So T1 raised to 4, so that is, but T1 value is 1000 and T2 500 raised to 4. So 2020, 5 2 and 2 raised to 4, 16. So this is our required answer for this part. Compare. So now we are done with this comparison or a rate of emission of heat. Now let's find out for the second part, ratio of their rate of loss of heat. Now rate of loss of heat, this term is there. Rate, when we are talking about rate of loss of heat, तो जब भी 727 पे रख रहे हैं उसको, जिसका टेम्परेचर 727 है उसको हम लोगों ने 27 डिग्री सेल्सियस में रख रहे हैं. देन देर विल बी रेट ऑफ लॉस ऑफ हीट व्हेन ब्लैक बॉडी इनिशियली इट इज एट टेम्परेचर 227, उसको आप रख रहे हो 27 पे. अगेन देर विल बी द रेट ऑफ लॉस ऑफ हीट. So that is why that rate of loss we need to find out, and the ratios here it is given. We need to find out that ratio. So let's find out. So sigma A T1 raised to 4 minus T0 raised to 4 and T2 टेम्परेचर के कंडीशन में वो कितना लॉस हुआ विथ रिस्पेक्ट टू enclosure temperature. So that is why T2 raised to 4 minus T0 raised to 4. Then this sigma A will get cancelled out. So let's put values now. So T1 is 1000 K. So 1000 raised to 4 minus T0 300 raised to 4 upon T2 500 raised to 4 minus 300 raised to 4. Now this 1000 is nothing but what? It is nothing but 10 raised to 3. This is 10 raised to 3 raised to 4. So that is why I can write 10 raised to 12 minus this 300 raised to 4. I can write it as a 3 into 100 raised to 4. Fourth power of 3 is 81. Then 100 raised to 4. So 100 raised to 4 means 10 raised to 2 raised to 4. So which is 10 raised to 8 upon. Similar way for 500 raised to 4 I can write 625 into 10 raised to 8, and for 300 again it is 81 into 10 raised to 8. 10 raised to 8 I can take common from numerator and denominator as well. So remaining term here 10 raised to 4. So that is why here I'll write 10,000 minus 81 upon 625 in numerator and denominator 10 raised to 8 is there. Then the 10,000 minus 81 is nothing but 9919, and in denominator 625 minus 81 which will give us 544. Now we need to do this by log. 20 log of 9919 is 3.9965, and a log of 544 is 2.7356. Then after subtraction it will give us 1.2709, and antilog of this number is 1.866 into 10 raised to 1, which is 18.66. So this is our final answer. So which is giving us ratio of the rate of loss of heat. Means 727 का 27 में रखने के बाद कितना लॉस हुआ, देन 227 को 27 में रखने के बाद कितना लॉस हुआ, इट्स रेशियो. So that's it. This is our final answer for question number 22. Thank you for watching.